Hi everybody, my name is Miss Lindsay and I am one of the youth and teen librarians here at the Winnetka Northfield Public Library District. Welcome to Full Steam Ahead. This is a monthly program we do where we explore the world around us and how things work via really cool STEAM experiments. This month we're going to be learning a little bit about oil and water, how they mix or don't mix, and what the repercussions are in nature. If you haven't picked up your kit yet, there may be extras available outside the library in our purple take and make bin on a first come, first served basis. But if you have picked up your kit, you'll likely find a small taped off container of olive oil. I have the bottle right here, a spoon, and some feathers. What you will need from home is a bowl. Any size bowl will work. I think I have a regular cereal size bowl here, and some water. Got a cup of water right here. I also recommend that you put down whatever you need in order to keep your workspace clean and dry, since we will be using oil and water, and that you're wearing clothes you don't mind getting a little messy, just in case. So in your bowl, you want to pour enough water to cover a few inches. This is where it's really helpful to have a grown-up who can help you do that without making much of a mess. So I'm going to pour just a few inches worth of water into my bowl, about halfway up in this particular bowl, but I have a very shallow bowl. It might be a little bit less if you've got a bowl with higher sides than mine has. The point is just to have a few inches to work with. It doesn't have to be very deep. The next thing you're going to want to do is you've got the feathers that you took from your kit. Take one or a couple, depending on how many you've got in there. I think each one has a random number. And dip it in the water. See what happens. If you've got a little bit of water and your feather here, it's likely going to float pretty easily. Not get super wet. If you dunk it under, it will get wet, but it doesn't retain a whole lot of water. It's really easy to clean off. It does take a little bit of time to dry, but not much. This is what happens when animals who have feathers swim in water. Their feathers get wet, much like our hair does, and takes a little bit of time to dry, but it's not dirty per se. It's really just wet. So you can see how it'll float or how it will sink depending on if you use your hands to make it sink. But if you try squeezing out the water, it comes out really easily. So for a moment, try squeezing out that water. And you'll see drops coming down from my hands into the bowl a little bit there. And it's still a little bit wet, but it's a little less wet, and it will take a little bit of time to dry. So that's a feather in just water. And like I said, that represents animals swimming in water. There are animals who live in oceans, lakes, seas, all different bodies of water, and a lot of them do have feathers, like birds and other animals. But what happens if, for example, there's a big oil spill? Take your oil in your little container and go ahead and very carefully, possibly with the help of a grown-up, pour your oil into your water. I'm going to go ahead and do that. You can go ahead and pour all of it, but pour kind of slowly and carefully, and don't touch it. Take a look at what happens naturally. I'm going to show you the bowl that I've got right now. What happened naturally here is that this is all oil here. Not only is it separate from the water, you can see a very clear line right here where it's separate, and it actually creates a really cool shadow underneath it. It's floating. If you were to look kind of under that line, you would see water. You wouldn't see oil sinking. That's because oil and water have different densities. They are of different levels of viscosity, and they don't necessarily take up the same mass in a bowl. So oil floats on top of water because it is a little bit, while you wouldn't expect it, lighter than water. That's why it doesn't sink. Anything that sinks in water is heavier than water. So it floats on top of the water there, and it doesn't mix with it because of the different levels of viscosity. So if you were to try and mix it up a little bit, it might temporarily mix. Mine is kind of making a really cool, almost like a lava lamp type bubble here, but it's not mixing up together. That's because they don't mix. So let's say, and this happens sometimes, a bunch of oil is accidentally spilled out into the ocean. What happens to those animals that are swimming around? Let's try putting a feather in the oil part of the water. Go ahead and drop your feather in. And unlike the first time where you could kind of see it floating, this time it's immediately soaking up all of that oil. If I touch my finger to the surface of the feather, unlike with the water, it's seeping up all the oil. It's not floating per se. It's actually taking up all the extra kind of oiliness. Now, if I pull it out, you can see that it's very shiny. It's retained so much oil. I'm going to give you a little bit of a challenge here. I want to see how long it takes you to fully clean off all of the oil from that feather. You can use whatever you have at home, soap, sponges, anything. But see how long it takes you, first with just water and then anything else you've got around the house. So I'm going to try with just water right now. And let me tell you, my hands are very oily. It's not coming off with just water. The water and the oil are not mixing. The feather is still covered in a very, very slick sheen of oil. And now so are my hands. It really does not work very well. So if you have soap, if you've got sponges, if you've got washcloths, if you've got old rags, use whatever you would like. Go ahead and pause the video here and see how long it takes you both with just water and then with anything else around the house and see what's the most effective. So go ahead and pause here. Unpaused? Perfect. So how long did it take you? A couple of minutes with everything else that you used around the house? A really long time with just water? I'll give you a clue. My oily feather is still totally covered in oil, and it's still sitting there. It's soaking in a lot of water. It's not going to come off very well. If you were able to get the oil off with just water, congrats. There aren't very many people who can do that. It takes a lot of work. It comes off much more easily with dish soap and gentle scrubbing from a very gentle sponge or rag. So if oil is dumped into the water, it actually creates a hazard for the animals because they get all slicked up in oil, and it's not what they're used to. They're used to just being wet. And if you felt the feather when it had oil on it and when it had water on it, they felt very different. Despite oil being lighter than water and floating on top of it, the oil feels slick and heavy, and it's not what they're used to compared to just being a little bit wet. So it makes it harder for them to swim or to fly, and it creates a hazard for them. So oftentimes when accidents like that happen, scientists actually go out to the sites of these spills and use things like dish soap and sponges, and they help clean up the animals. So that's a really interesting example of oil and water not mixing and being in nature. But there's lots of different examples of how oil and water don't mix. If you have a bottle of salad dressing in your fridge and you open it, take a look at it, often you'll see that it's separated because the liquid and the oil in it don't really naturally mix. You have to shake it up really, really a lot before it'll mix up and actually make the salad dressing that you like. If you look at a lava lamp, it's oil and water, and when you put something in there to constantly stir it, like whatever the compound is in there, if you want to make a homemade one, it's oil, water, and a little bit of Alka-Seltzer. It's the same thing. They won't mix. They'll just kind of dance the way they did when you stirred it with your spoon, because it's like a constant form of mixing because the Alka-Seltzer creates really cool bubbles. There's lots of examples of how different liquids of different viscosities don't mix. What other ones can you name? Send your examples to us at youth@winnetcalibrary.org. We'd love to hear all about the results of your experiments, what you learned, and what you'd like to learn with us next, because we do these every single month. Thanks for joining us, and we'll see you next time.